In this video, I will show how to use the integration by parts to evaluate the definite integral. However, first we have to use the trigonometric identity, and notice that sine of 2x can be written as 2 times sine x cosine x. After that, we have to do a substitution, and the new variable will be cosine x. So we're going to choose t to be cosine x. Since I have a definite integral, I have to change the limits of integration. So when x is 0, t is 1. When x is pi, t will be -1. And to complete the substitution, I'm going to find all of these expressions in terms of t. And let's see, so derivative of cosine x is negative sine x dx, and e to the cosine x will simply be e to the t. Now we're ready to substitute. So the original integral now becomes integral from -1 to 1, or I should say from 1 to -1. We have e to the t. Sine x dx now becomes negative dt. So we have this -1 dt, and I have that extra cosine x, which is t. So factoring negative and flipping the limits of integration will give me the following integral. And this is one of the integrals that we do by using the integration by parts technique. And this shouldn't be the first time we do that, so we know which expression to pick as a u function and which expression to pick as dv. So u is t, dv is e to the t dt, then du is same as dt, and v is same as e to the t. Now we have 2 times uv is t et, and now we're going to evaluate it from -1 to 1, minus integral of v du. So we're going to distribute that 2 from the front of the integral and write this integral from -1 to 1 of e to the t dt. Now we can evaluate t et at 1 and -1, so we have 2 times 1 e to the 1 minus -1 times e to the -1 minus, and now we can evaluate, well, first we have to find the antiderivative of e to the t, which is e to the t, and then we evaluate it at -1 to 1. And now we just have to plug those values in and simplify. So we have 2e plus 1 over e minus 2e to the 1 minus e to the -1, which is 1 over e. And this can be simplified further, so we have 2e plus 2 over e minus 2e plus 2 over e. So the answer is 4 over e. So we evaluated the integral by first using a substitution and then integration by parts.